Such a long one, but anyway. And the second one is going to be our parametric equation. What we're used to are equations like this. Y equals x cubed minus 7x squared plus 5x minus 3. We don't usually call them this, but these, comparison-wise, these are Cartesian equations, referring to basically the fact that, you know, we graph that, we've got x, we've got y, right? And so the y is related to the x this way in the Cartesian coordinate system. So we can refer to that as a Cartesian equation. This right here is what's known as a parametric equation. So let's notice a couple of differences about the parametric equation. The x and the y here, notice, I've got x and y defined, but they're defined in terms of a third variable, t. And so this t, yeah, is the same as that t. So I've got a third variable here, and that's called, the t is called the parameter. Hence, this is a parametric equation. So it's the idea of assigning the x and y values through a third variable called a parameter, t. T is the parameter. And we'll use that mostly for the parameter. But you could use theta. T could be thought of, the reason you do this, just to give you an application of it, you can define lots of pretty wild curves very simply, and a lot of them use sines and cosines, but you can get a lot of weird wild curves out of this, whereas, you know, Cartesian equations, we're usually thinking functions, one-to-one, or vertical line tests and all that. You can switch the x and the y's and get some other things, but with a parametric equation, we can get all sorts of loops and all sorts of, we'll see how it goes out here, but the parameter is usually, you can think of it either as an angle, t is like the angle on the x-axis or from the x-axis, you know, like in our trig functions, theta, you can think of that, t is like an angle. Can be time. That would be very easy, t for time. As progression of time, x changes this way, y changes that way, as according to time. So there's lots of applications for using parameters. But the key thing here is, yeah, if I have a parametric equation where x equals some function of t and y equals some function of t, each value of t determines a point xy. Just like we've got an xy point here. Same thing with the parametric equations. Each value of t would give me a x comma y, right? If I said t is 1, t was 1, I would get an x value and I would get a y value. And so it's just like that. It's an ordered pair. So as far as graphing is concerned, it works much the same. Okay? All right, so let's take a look at an example here. We'll just sketch some curves because, of course, we want to relate it to our calculus ideas as well. But let's just start sketch the curve. That's what they say. And we will do this one, first of all, by hand, by table, whatever you want to call it. Sketch the curve x equals t squared minus 2t. Y equals t plus 1. Is that the same thing I had? I think so. And then negative 2 less than or equal to t less than or equal to 3. We've got a boundary on our parameter there. And so one way we can do this, like I said, to sketch the curve by a table is, well, just like we did tables before, except our x's and y's are defined in terms of t, so in our table we're going to use t values. And in this case we're going from -2 to 3. So how about we do -2 to 3 integers. And then you just plug it in, get the x, get the y, see where that goes. All right. If t is -2, what do we get for x and y? Well, x would be what? 4 plus 4 would be 8. And y would be yeah, that's 8, isn't it? And then y would be -2 plus 1, so that's -1. And so that will give me the point 8, -1. Okay? That's all we're doing. We're just plugging in t values instead of x values or y values. Just plugging in t values. All right, so what do we get for -1? T is -1. We get -1 squared minus 2 times -1. Hey, that's 1 plus 2. That's 3. The y value would be -1 plus 1. That's 0. When t is 0, x is 0, y is 1. When x is 1, what do we get? 1 minus 2 would be -1. 1 plus 1 would be 2 for y. Check me on these. When t is 2, we get 4 minus 4, that's 0. And 2 plus 1 is 3. And then when t is 3, we get 9 minus 6, that'd be 3. And 3 plus 1 is 4. Did I do those right? 8, -1, 3, 0, 0, 1, -1, 2, 0, 3, and 3, 4. All right, so yeah, we're just going to then, graph-wise, just plug those in on the graph. 8, -1. It's right there. And that's called our initial point right there. I'll make a point about this in just a second. All right, then we go to 3, 0, 3, 0. Then we go to 0, 1, 0, 1. -1 and 2. And 0, 3. And 3, 4. So we got this initial point, and this is our terminal point. Some of them will just continue. I mean, you can kind of see where it's going to continue around, but since I've defined my parameter boundaries there, here's what I've got. Initial point to terminal point. And then one other thing they like to note on these, because of the time thing and the angle thing, is they do like to show the movement here. As we go from t is -2 to t is +3, the arrows indicate, yeah, we're going around here like that. So if they ask you to put arrows to indicate the direction of movement, that's all they mean. We started here at the initial point and went to that terminal point. Okay? All right, and so you can see there, this is going to be a sideways parabola, isn't it? But we can define it with parametric equations. All right, here's another one. Let's do this one again by a table, just to kind of get the feel for what's going on here. We're going to do these with a calculator more often than not, but just to get the feel. Is that all right? Any problems with that? Okay. Here's another one. Sketch the curve by table. By using a table. All right, this is going to be x equals cosine t, y equals sine of 2t, and we're going to go 0 is less than or equal to t is less than or equal to 2 pi. And so here, obviously, what's t basically playing the role of? It's obviously an angle, right? But let's see what happens. Now, when you do these angle ones, so we got t, then x, then y. we're going from 0 to 2 pi. Now, probably don't want to go 0, 1, 2, 3, right? Because t is basically an angle there. You might want to do some pi angles. Let's see, what did I do? Pi over 4s. I did them by pi over 4s. This one's 0 to 2 pi. So pi over 4s give us a pretty good accurate picture. So go 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, where am I? 7 pi over 4, and 2 pi. And so that'll give a pretty good accurate picture for x's and y's. Okay, so I can do some of these. We'll just do the decimal ones, approximations if we need to. All right, so if t is 0, we've got cosine of 0, that's 1. If t is 0, we've got sine, for y, sine of 0, which is 0. Pi over 4, cosine of pi over 4 is square root of 2 over 2, but we'll just say that's 0.707. Map it on the graph that way. And then we have sine of 2t, so that'd be sine of 2 times pi over 4. That'd be sine of pi over 2, wouldn't it? Which is sine of pi over 2, 1. All right. Then we go to t is pi over 2, so we have cosine of pi over 2, which is 0, and sine of 2 times pi over 2, that's sine of pi, so that is 0. 3 pi over 4, okay. I said I'm just going to, probably should know those, but you know, you just do your angles things here. Cosine of 3 pi over 4, it's negative 0.707. I got off track here. It'd be sine of 2, so it'd be 6 pi over 4, sine of 6 pi over 4, 3 pi over 2. It's negative 1. I'm way off track here. Okay. All right, pi, cosine of pi, negative 1. Sine of 2 pi, 0. Okay, 5 pi over 4. Cosine of pi, pi over 4. It's negative 0.707. Square root of 2 over 2. Sine of 5 pi over 2, which is 1. 3 pi over 2. It's cosine of 3 pi over 2, 0. And it'd be sine of 3 pi, which is 0. Got lots of zeros here. That's why I did the pi over 4s, I think. 7 pi over 4, well, that's positive 707, square root of 2 over 2. And then sine of 7 pi over 2, that's back to negative 1. And then for 2 pi, cosine of 2 pi, all the way back around, that's 1. And cosine of 4 pi, that's 0. So anyway, with me? Believe all that? Think that's all right? Well, this is what I'm saying. We get some kind of interesting little curves. All right, so I'm mapping these, plotting these, 1, 0. And I might want to do this. Let's make it 1 out here. Okay, so I spread it out a bit. Make 1 out a little bit there from what we usually do. So I've got 1, 0. Then I've got 0.7071. So 0.707, how about right there? And there's 1. Then I've got 0, 0. So I'm back here at the origin. And so if I just plot the direction here, I've kind of gone here. And it is rounded. See that? All right, then where do I go? Negative 0.707, negative 1. So here's about negative 0.7, then negative 1. And then I'm at negative 1, 0. Then I'm at negative 0.707, positive 1. And then I'm at 0, 0 again, so I've gone kind of around the world here. And then I wind up going completely around the world because here we go. Kind of looks like a infinity symbol. Small one. What do you think? Interesting little curve, isn't it? And that's just using cosine t sine of 2t. Very simple curves, but that leads us, parametrically speaking, to a nice little graph. Okay? Now, like I said, good to know that these things, how these things work. We're choosing t's that gives us the x's and y's. How these things work out. Now, what will be very helpful will be our graphing calculator tool right here. That'll help us. There is a parametric mode on graphing calculator. You have to change mode though. On the TI 83s and 84s, it's pretty easy. Just go to mode. And then on the 4 lines down, on the TI 83s, 84s, you see function, par, pole, and seq. SEQ. We want par. Par for parametric. Yeah, if we put it in parametric mode, of course function mode is what we normally are in, but if you put it in function parametric mode, just go to it and enter, hit enter, and that changes its mode for the TIs. Now, that's what I'm talking about. Then if you go to the y equals screen, what do you see? Yeah. If you go to the y equals screen, then it's not really y equals anymore, is it? It's y1, x1t, how does it look on these? x1t, y1t equals. They got a line here. And then they've got x2t, y2t equals. So yeah, these are then paired up parametrically, right? So this is saying I'm going to define x in terms of t. Well, let's check our little work here. Let's do x1t as cosine t, and y1 is sine 2t. Now, here's the thing. I think it's normally set up by default to be negative 2 pi to 2 pi. I don't think it'll matter here, but just be warned. If I want 0 to 2 pi, then I go to my window. Well, I didn't put my thing in there. All right, cosine t. And to get the t, you just hit the x. What we normally hit is the x button. It'll put in t then if you're in parametric mode. And then we do sine of 2t. Okay? And then, like I said, to get this particular parameter, 0 to 2 pi, just go to window on the TIs. On mine set up. 0 to 2 pi, which is 6.2283. You can change, it's got Tmin and Tmax, and we want Tmin to be 0, Tmax to be 2 pi. And it, on the TIs, it adjusts it to decimal, 628, or mine does anyway. Does yours do it? Okay. 628. And then, you know, on the T step, that's kind of like the scale. You know, we did it pi over 4s, but that was just because I didn't want to do a whole lot of hand calculations. So we do want the T step here to be probably a little more. Let's see. Let me see what mine is. Is yours 0.13? So that's pi over something. 24? Yeah, I think it's set up to be pi over 24. So that's a pretty good step. It's doing a lot more than we're doing. Okay? And then your scale, your scale is the same. That's just what you want to see in your window there. So x min negative. So I don't need it very big, so let's just say x min is negative 2 to positive 2. And same thing for y. See if we get that. Hey, crap. Ta-da! Yeah, you're in degree mode. Be sure you're in radian mode too. Yeah. Yeah. Yeah, be sure, your angle mode, be sure you're in radians. That's also the mode you need to be in here, not degrees. Okay. All right, so yeah. Like I said, they use pi over 24. I think that's default. So yeah, these will be nice for us. Okay. All right. So graphing, no problems here. Matter of fact, if you want to go back and let's check the other one. The first one was x equals t squared minus 2t. Y equals t plus 1. We went from negative 2 to 3. See if this is what we get. See if we got a match there. T squared minus 2t, t plus 1. And we want, to get the exact match, we want negative 2 to 2. So t min is negative 2, t max is positive 3. T step, leave it there. Oh, we'll have to change our window, won't we? X max needs to be maybe 10. No, it needs to be a little higher. Oh, Y max, Y max.